Dope. Yeah, I just saw your message on Twitter. I'm sorry I didn't respond until like now.
No, it's all good.
My my Twitter is just, have a lot of backed up messages sometimes. It's hard to keep up.
Yeah, you have a pretty big DM list, I bet.
Yeah.
Um, well, yeah, thanks for joining us.
Yeah, for
Pretty
sure.
much all of us were blockchain at Cal Poly. We're a pretty small group, but we're really interested in like kind of being in a position where you're in, a developer. Sorry about the noise in the back.
So you all are like attending school there, and you're also part of this association within the school, I guess. Okay, cool.
And then last week we had a meeting. Just a couple of us were going over like the graph,
Mm-hmm.
and I tried to make a subgraph for one of my projects. Um, and I still have to do a little bit more where I need to like, I guess, add in the specific like smart contract events that I'm trying
Mm-hmm.
to query into like the actual schema of the subgraph.
Mm-hmm.
But once I get that figured out, then I pretty much have everything I need.
Cool. I'm gonna hopefully be able to walk through that whole process today if we have time.
Yeah. And that's kind of what your plan was for the talk, the
Yeah, it was going
graph.
to be kind of an overview of the graph. Are you kind of the only one that's used it, or all of you all have tried to play around with it?
I've read on it and kind of understand what it does, but haven't actually implemented or used it so far. But hopefully
Okay,
one
good.
day.
Good. So I think this will be helpful then. So I just was making sure I wasn't going to be going over some stuff that you all like already knew. So this will be like an introduction to the graph, and then I'm going to attempt to build a subgraph from scratch and deploy it and test it out.
Right now,
Mhm.
we
I might not be walking through every little piece of code, but I'll walk through most of it because I'm going to be doing a fairly straightforward subgraph for an NFT smart contract, and all of those are pretty much the same.
mhm.
So
I didn't see you coming. I think
Who's
Not your
that?
own audio. He's in his car.
I just enabled screen sharing for all participants.
cool. Yeah, just let me know when y'all are ready. Kick things off, or if you saw a few more people that might be coming through. No rush.
I'd say this is probably gonna be it. Maybe
Okay.
a couple more. Couple, people are showing up now, but I'd
All
say
right, cool.
we could get started.
All right, do you want to do any type of like intro overview of that you typically do for these sorts of things, or you want me to just go ahead and jump into it?
I guess, do you think you could start by introducing yourself and kind of your background and then how you got into the space?
Yeah, I would love to do that, and I would also love to hear more
Watch.
about the college itself. And there's probably some history and stuff about the school that I might not be aware of, and there's so many schools out there. I'd love to hear just a quick overview of what you know you all, or why you maybe have chosen that school. I guess might be interesting to know, as well as like some of the things going on there. But yeah, for me, my name is Nader. I'm a software developer of about 10 years. I've been with Edge and Node and the Graph protocol for about 1 year. I started kind of interviewing with them actually in February of last year, and I joined in April. So I've been there 10 months, but I've been kind of like, knowing the team for about a year. And if you think of the way that Solana has Solana Foundation, which manages the treasury and oversees kind of the development of the Solana network and all of the code to kind of run the network, I guess. They also have Solana Labs. Solana Labs is kind of like the private company, and Solana Foundation is kind of like the foundation that's nonprofit. We have something similar like that with the Graph. So we have the Graph protocol, which is a foundation, or I would say the Graph Foundation manages the protocol. And then we have Edge and Node, which is a private company. And I work with Edge and Node, but we work very closely with the Graph. So I kind of use both of those teams interchangeably because we work so close with each other. Before I joined the Web3 space, I was working at AWS for 3.5 years. Before that, was running a consulting company for a little over a year called React Native Training, where I was teaching software developers around the world how to build mobile apps using JavaScript and React. So most of my clients were pretty large companies like Amazon and Microsoft and I don't know, some banks and even like Warner Brothers, where they had like these native teams where they were writing code in like Objective-C and Java, and they wanted to take those developers and turn them into cross-platform developers. So I did that for about a year and a half. Before that, I was a front-end developer for about 4 years. And yeah, so the reason I came into the Web3 space was actually I was at the end of 2020, I was reevaluating my options as for my career. I was just interviewing at a few places, and I had, I was a pretty senior level person at Amazon. I was in the path to become a principal, which is kind of like, a pretty big thing. It would have been a pretty big thing for me there. But I was also thinking like Amazon was getting a little bit boring, and I also was just considering other options. So I was interviewing at Coinbase, Goldman Sachs, and Bridgewater. So I think it's good to give this type of context because people sometimes wonder why I'm in Web3. But when I tell them like the background, it becomes a little bit more meaningful. So I had a really great, comfortable position at AWS on the road to principal, but was also interviewing because I wanted to kind of try something different. I had within like maybe 2 weeks time, I had 3 offers come through. One was Coinbase, creating the developer and running the developer relations team globally at Coinbase. I had an option to do the same thing at Goldman Sachs. Both of those teams would have been like 10 to 20 people like underneath me, and it would have been pretty cool opportunities. But the thing that started really gaining my attention was Web3 at the time. It was very, very early. Like no one was, I would say, talking about it as much as today. Yaniv Tal, who's the founder of Graph Protocol and the founder of Edge and Node, has a talk from 2019 where he was talking about it. And of course, people have been talking about it like way before that. But the talk that I saw was from Yaniv, and it was like really compelling. And it was so compelling that it made me just like not want to work at any of these companies. And I wanted to find a protocol to work with, or a Web3, like a truly decentralized like protocol or a company to work with. So I decided to do that. So I kind of like within the course of maybe 48 hours of researching, I decided that I didn't want to accept any of these offers or stay at AWS. Instead, I wanted to try something completely different, and started like researching all these protocols. And within about a week, came back around to the Graph protocol because I had GraphQL experience, and I decided to apply there. And then I ended up getting, an offer there, and that's where I'm at now. So a lot of people that I talk to are starting to kind of like have similar stories where they like leave Google or they leave TikTok or like these really great, in the past you would have thought of as like the ultimate like career, opportunity to kind of go into some weird brand new protocol that's only been around for like 6 months or a year sometimes. And it's becoming more and more common because all of us really enjoy like working in this space. And but you're also seeing now Google and these other companies start actually building blockchain teams. So that's also compelling. Like I could see where that would be a cool opportunity. And I'm sure that those opportunities might be more stable and they pay a lot. They pay really well. I wouldn't say better, but they definitely pay well. So yeah, that's kind of my story. And then today I'm going to be talking about the Graph, and I'm going to be talking about what it is, how it works, and how to build an API with it.
Awesome. Love it. Yeah, you have a pretty interesting backstory. And I like how you have a little bit of some interest in finance, it seems like,
Yeah, I
because
was
you were
very
interviewing with
interested in
Goldman Sachs.
finance. Like for the last year before I got into Web3 and blockchain, I became interested in finance. My friend was working at Citadel, like high frequency trading, and I started like diving into that area a little bit and getting interested in that. The front end engineers there like getting paid between like 400K to like $1 million a year, you know, as if you're a really senior. So that was when I heard about that and I saw like his lifestyle like changing. That was pretty fucking cool. And I was like, you know, thinking that it also seems kind of exciting to be in the high frequency trading. So I was investigating that stuff, and I thought that Goldman Sachs would be, you know, and Bridgewater would be kind of like the two areas that might get me into that space a little bit. But I ultimately decided not to. Yeah.
I have a quick question before you start too, if you don't mind. Because I was kind of looking through your guide in kind of Web3 stack. So obviously a lot of this is very new stuff. How did you go about compiling these resources and things before like you put your guide together?
Yeah, so we had a team at Edge and Node that's been working on, like, we had 2 researchers for most of last year and then 1 researcher for like the last few months because that person went on to something else that was focused on compiling all of the protocols and tools and things that were out there, because there's so many things out there. Like literally I hear like 5 or 10 things being launched every day, like if you keep up with all this stuff going on. So it's impossible to just know like if anything is worth looking at sometimes. So it's very, very noisy. So we had a team of researchers that literally like spent the entire year last year researching the tools, protocols, and stuff like that for the Web3 stack. And then they would sit down and have interviews with the teams and stuff to try to understand whether these teams were building and they were kind of like continuing to have like a future roadmap, or if they were just here to just, you know, launch something and play around with it, or if they were serious. So the Web3 stack blog post was kind of like a compilation of the projects that we think are pretty serious. There's one thing in there that we need to probably switch. It's the ThreadDB team kind of like pivoted into this new this new SQL type of data store, but it's kind of the same idea, but they renamed it and stuff. But like pretty much everything else there is pretty relevant.
Awesome, thank you.
I guess if there's no other questions, I can give a little rundown of like who we are as a club and kind of what we want to focus on. So our university, Cal Poly San Luis Obispo, is primarily an engineering university. So a lot of students come here for like mechanical engineering, computer science, and it's, I guess, known as like one of the better engineering schools in California. So most of us here are computer science, and that's what attracted us to the school. Yeah, I guess I'm speaking on behalf of like everyone here, but if you guys have your own things to share, you can. And yeah, so I actually went to the blockchain club my freshman year, and that's how I met one of my friends, Eric. He kind of brought me into the whole crypto space, and I saw that they were doing like Solidity tutorials. And this was, back in like 2019. So pretty much the only thing going on at that point was, like make a ERC20 token, like maybe make a landing page for it, mint it, send it to people's wallets, all that kind of stuff. There wasn't a lot of like DeFi projects. So I didn't really know anything about that until like very recently, when all that stuff started popping off during the pandemic. And during the pandemic, our club wasn't very active. So I kind of took the initiative to like bring us all back together. And most of us are like juniors and seniors anyway. So it's kind of our last opportunity to get involved in like a space that'll maybe lead to jobs after we graduate. Yeah, pretty much because we want to get jobs in this space, like we're just trying to learn all of the tech and maybe focus like less on the investing side, less on just kind of like the cryptocurrencies in general. And we're also like trying to be really aware of Web3 and like the creator economy, all that type of stuff.
Okay. Cool. Is there any certain, like, what does the curriculum look like for blockchain at university, like where you all are studying it? Do they focus on like Solidity, or they focus on Rust, or they focus on like a lower level language?
So there's no actually official like blockchain curriculum at our university. I know
Okay.
there's
So it's like computer science, and then you all are just doing your own thing.
yeah, yeah. And I'd say like the subset of people that are interested in computer science and the subset of people out of that who are interested in blockchain is really small. Um, so there's honestly not a lot. Like you might go talk to some finance professors who are really into like cryptocurrency, and they'll say like, you know, maybe we'll offer a class in DeFi couple of years down the line, but who
Mhm.
knows? As
Got
of
it. Got it.
now, kind of we're kind of just doing this all like ourselves. There's not too much structure to the club. We kind of just meet every week, talk about cool topics, look at cool tech like the graph. Um, yeah, and we're just trying to gain skills. So
Mhm.
primarily like learning Solidity and React development.
Cool. Cool. So what time do we have until about the hour? Like 40 minutes
Mhm.
from now, or okay, or 20 minutes?
Yeah, well,
12. Okay, cool, cool. All right. So yeah, you ready for me to go ahead and kick this off, I guess, on my end? Okay, cool. So let me go ahead and share my screen. So you see this? Okay.
I kind of it it's kind of cutting off like the outer edges.
Okay, yeah, yeah. So let me make this a little bigger.
You have like a super long monitor or something?
Yeah, yeah, yeah. I'm trying to make it like fit. Does something like that look all right?
Mhm.
Okay,
Yeah.
cool. Um, all right, and I have a little presentation here. So as I was introduced, yeah, my name is Nader. I work with Edge and Node. Um, and we're gonna be talking about the graph. But before I go into that, I just want to kind of like review this post that we actually mentioned just a second ago called Defining the Web3 Stack. And the stuff that kind of went into this, we ended up like creating a diagram, and we've created a few pieces of like, I would say like we've created tutorials and guides and stuff. And we actually have some like actual research, like white paper that we're working on here around this stuff that is done by the actual researchers, as opposed to just me consuming all of the information that they've put together. But the idea around kind of like talking about the Web3 stack in general, it's kind of for developers coming into the blockchain space. There are literally like thousands of different protocols and tools and things out there. So if you want to kind of become a developer, it's often hard to figure out what to use, and what things are actual useful, and what things are mature enough to actually use. So we kind of put together like that blog post that was hopefully trying to kind of condense a lot of that stuff, just to, if you wanted to just get started building something and you didn't want to kind of sift through all of this stuff, and you just want to have like a getting started guide, this would be a good place to start. So we decided to take that, turn it into like an image, and this image is really nice because it's easy for people to just check out and share and consume. But when you think about building applications in the traditional web space, like if you wanted to work on AWS or something like that, it's very easy conceptually as a developer to understand how to put all these things together, because almost every application works exactly the same. You typically need a server, you need a database, you need some type of file storage, and then you need a client. Either that would be a mobile or web app. And from there, you can pretty much accomplish 95% of what you want for almost any application as a software developer. The other 5% might be something like machine learning or something like that. But if you want to build a prototype, you can kind of like conceptually grok what it takes to do that with just these core primitives. So in Web3, those primitives are not yet, or were not so well defined when I started trying to understand what that looked like. And I think like putting these things together helps conceptualize like what that stack looks like. So in addition to like file storage and maybe the concept of a database, you have much different things that kind of maybe fit partially in some of these same compartments. So one of those is identity. And the traditional web application space, we might identify a person by their username, but in an attempt to have some type of secure way to kind of allow them a way to regain their identity if they kind of lose their email, or I'm sorry, if they lose their password or something like that. We typically ask them for some personal information. So we end up asking them for their email address, or we might ask them to OAuth using Facebook or Google, and then we kind of store that personal information in a database somewhere, like a centralized database. A core difference with most blockchain tech is that you end up identifying and authenticating, authorizing a user through their wallet using public key cryptography. And all you ask for them is to like maybe sign a transaction, and either within the smart contract itself or maybe on a server, you can authenticate that that person is who they are. And all you know about them is their address. Like you're given this anonymous address, you don't have any personal information tied to it. So like that is identity. And like each one of these is maybe a little different, or a lot different than maybe working in the traditional space. So we tried to kind of break these things apart and, give the developers, okay, I want to build an app and I need file storage. Okay, here's a list of like different tools or protocols you can use. How does identity look? Okay, you might use something like Wallet Connect to connect to their wallet. You might use something like Self ID to implement self-sovereign identity, or Spruce ID. So yeah, anyway, so like the graph is a protocol that kind of fits into the stack. And I'm going to talk about why that is the case here in this presentation. So like if I was going to give a definition of the graph is an indexing protocol for querying blockchain networks. And that might sound kind of obscure. So we'll kind of talk about a little bit more of that in depth. When we think of a traditional database, databases are optimized for both read and write operations. If I need to do something like sorting or filtering or full text search or even relational data, combining my server and my database, a highly optimized database that's been iterated on for dozens of years, often like a SQL or maybe a NoSQL database, I can pretty much get any selection set I need from my data, and I can kind of bring it back to the client and serve it up in my application. But in blockchains, the data is not made available for querying like we're used to in traditional databases. Instead, we have this data that's been stored in these blocks over the course of time. So every time a new block is written, more data is saved to the network, and then this continues on. So if I want to read information, I can often read directly from the smart contract using a function that's been written there at the point in time when that query was made. But I can't ask for any type of rich querying capabilities. So I can't say, give me all of my friends from this person. I can't say, let's search for any transactions that have the word like with my username in them, those sorts of things. So typically, to get around this, developers would often build out their own centralized indexing servers that would essentially save all this data in a database and then kind of build out their traditional API on top of them. So looking at a traditional database, again, kind of like what you end up usually happening is you have some type of execution environment. This is typically a server or maybe a serverless function in the serverless world. The server will talk to the database. And then within this execution layer, we have our own arbitrary code that we can write. We could say, okay, we have this array of users. Let's filter those users and only get the ones that maybe are like friends with us or that like to tweet or something like that. And then we just kind of return that to the client. So again, like this isn't built directly into the chain. So what we end up needing is some type of indexing layer. So that's essentially what the graph offers. And when we think of an indexing layer, a good example of an existing indexing layer that we use every day is Google or a search engine. When we want to search the internet, we're not actually searching the internet. We're searching a database that Google has created for us. They've gone around and they've looked at every single website in the world, and they've saved some relevant information in their databases. And then when we query the Google API, we're talking to their databases. Another good example of an indexing layer is a Dewey Decimal System. So if you go to the library, you don't have to kind of walk around the entire library. You can go to this index and find exactly where it is, and you can know exactly where that data is. So the graph is a protocol that allows the indexing and the querying of this blockchain data. And it sits in between the smart contract and the user interface. So instead of talking directly from the UI to the smart contract, you have this subgraph, this API layer that's sitting in between, where you are given a really rich API endpoint that you can then hit with all these different queries. And then once you're querying from your front end application, you're now querying the graph network, which is a bunch of these hosted indexers that are running on the network that are serving this data. And instead of kind of relying on a centralized source of truth like you would in a traditional web application, you now have a network of nodes that are serving up this data. So if a single node goes down, again, it's almost like the Ethereum network or any blockchain network. You're not relying on a single source of truth. You have a network that is keeping that data in sync. So the graph network has a couple of different participants to make this work. We have the indexers. So indexers are the developers that are running the actual node, the software itself, and they can launch their own indexer to the network, and they stake GRT, which is kind of our token. And they're staking their token because they're essentially wanting to put up their, I would say, like money almost, to say, okay, I'm going to be running this and I'm going to be serving up the information for the network. And in return for staking these tokens, I want it to receive in return a portion of the query feeds that the developers or people that are paying to access the network are paying. And then we also have like this network-wide inflation. So tokens get distributed throughout the network throughout the year, and then the index will receive a portion of that. And in addition to that, one of the reasons that they have to stake tokens is if they are serving up the wrong information from their indexer, then they get penalized and they lose a large portion of those tokens. So when you're querying data directly from a blockchain network, you can assume that that data is correct. But once you have someone saving that information in a database, you need to provide an incentive mechanism to make sure that they are actually serving the proper data. So the network has this incentive mechanism in place. So if someone is serving the incorrect data, then they can get penalized, and we call that slashing, and they lose a portion of their stake, and therefore they are penalized. And there's also a role within the network for people to actually, we call them fishermen, where they go and they look for opportunities to slash indexers. So if you wanted to make money, you could literally go and find an indexer that is performing, improperly, and essentially kind of flag them, and they would be slashed, and you would earn a portion of that slashing, whatever. We also have subgraph developers, and that's what we're going to be focusing on today. Subgraph developers are the developers that just build APIs and deploy them to the network. Curators are people, anyone that is a network participant that looks at a subgraph that someone's created, and they can stake their tokens to signal that they think this subgraph is of a high quality. And in return, they also can earn rewards. So if I see a really great subgraph that's been created by someone, I can basically say, hey, I want to curate on this subgraph, and I want to put up some of my tokens, and in return, I will earn rewards if that subgraph is being used. And then delegators are kind of the last network participant. If you are not a technical person and you don't want to run your own infrastructure, you can just find a indexer that you trust, and you can essentially kind of like stake your tokens or delegate your tokens to that indexer. And then in return, you will also earn query rewards. So if you're like someone with tokens, that's kind of how you might participate. So we now actually serve over 2 billion queries per day. This slide is a little bit outdated. A lot of projects in the Web3 space use us, including like Decentraland and Uniswap and Foundation and NFT marketplaces and DeFi marketplaces and stuff like that. So we're going to now walk through how to build a subgraph, and then I'm going to actually build one from scratch. You know what? Instead of going through these slides, I might just jump right into the code, because it will be very repetitive if I do it this way. So yeah, let's go ahead and jump into some code. does that text look large enough, you think?
Yeah, it's large enough.
Okay, cool. Yeah, it's pretty big. I just want to make sure. All right. All right. So what I want to do is I want to create a new subgraph. And what we want to do is we want to create an API for this NFT called Crypto Coven. So this is just a smart contract that's been, deployed to Ethereum mainnet, and now they're on OpenSea. And essentially what we want to do is create an API that kind of allows people to not only just get all of those NFTs, but let's say we wanted to kind of drill down and look at one of these, and we see that they have these different properties like their eye color and their background and all this other stuff. And they even have like a description, and we want to be able to, and a name. So we want to be able to query and search and stuff like that using all those characteristics. So that's kind of what we want to do. So to get started, I'm going to go to thegraph.com. And I'm going to go to the hosted service. So we have the subgraph studio, which is what you would deploy to the actual decentralized network, which is what I was going over earlier. But for an example like this, I'm going to deploy to a centralized hosted service, which is kind of more of it like a place I would consider if you were just testing things out and you wanted to kind of, play around. And also you might deploy here if there's certain features that are not yet supported in the network. The network is more stable. So like you're going to have less issues with your actual API going down and stuff. The centralized service is more of a traditional like centralized service. So I'm going to go to thegraph.com, my dashboard. I'm going to click add subgraph here. And I'm just going to do that CTP API. And I'm going to give it a subtitle of something. And the title and the subtitle don't matter a whole lot. So NFT API. And then we'll create the subgraph. And here we're given just our dashboard. And now that we have this created, we can go ahead and kind of like deploy our subgraph to this. So now we actually need to create the subgraph. So using the graph CLI, I can initialize like a new boilerplate project. So if I just type in graph and the binaries there, then you should see that we have, graph -- help. We should be able to go ahead and run a command. And to install this, you would just run npm install -g, and you can find all of that information on our docs. So to initialize a new subgraph, you can run graph init, and this will kind of walk you through a bunch of steps like protocol and things like that. You can also pass in a few flags. So I want to pass in the from contract flag. Also want to specify the network is Ethereum mainnet. I want to set the contract name as token since it's an NFT, non-fungible token, and then index events, which is something I'll cover in a second. So how would I get like all this information? Well, if we go to the back here where this NFT is on OpenSea or wherever, you can actually go down here to Etherscan. Let me close all these. And you can just like open up one of these transactions, and this should open an Etherscan. And here you will see the actual contract here where it's been deployed. And if I go, let's see here, if I kind of like, well, let me just copy this here. Well, actually, let's look at this address. It's 0x518 and it ends in AC8. And if I go here, you'll see 0x518 and it ends with AC8. So that's like how we got the contract address. How do we actually get this metadata? Like, where does this information come from? Well, if you go to an ERC 721 contract and you go to the read contract, there's a function called get base URI on almost every NFT contract. And this gives you the IPFS URI. And you can actually just take this and just go to ipfs.io/IPFS/that, and then just type in whatever number of token that you want. And then you should get some JSON back. And this is like all of the metadata. And then you can actually just open up like all the other information that you would want. So we have like the image, we have the external URL, you have the attributes, the description, the name, all this stuff. So using the combination of the smart contract address that we just looked at, forgot where that was. Okay, right here. And the IPFS endpoint, we can actually just build our subgraph using those two properties. So those two things are going to be like the main things we leverage. So I'm going to go back to my terminal, and index events is really powerful because the way that we actually get the information off of the contract is through the transactions that have happened for the deployed contract. So if we go to transfers, like each one of these different transfers is an actual like transaction. And within this transaction, we are having an event essentially fired that we can then do stuff with. And the main way that we're going to be actually working with these transactions. So like you can think of every transaction as like a piece of data that you can work with. So in this transaction, you have things that have happened, and you have logs and you have state and things like that. And for instance, we have this approval, we have this transfer that were both fired. These are two functions. And in this transfer function, we have a couple of arguments. We have an address, and then we have a token ID. So like the way that we index data within a subgraph is by subscribing to different information out of these different transactions. Now you can get the information off of the transaction in, I would say, like 3 different ways. You can look for an event to be emitted, and in the ERC 721 contract, certain events are automatically emitted. So when someone does a transfer function, the transfer event is fired, and we can like listen to that event within our subgraph for it to kind of be triggered. You can also just say when a function is invoked, we want to do something with that information. So there's like a couple different ways, but the main way that you're going to be working with this is the events. So if we go to any ERC 721 contract, you'll see that there is this transfer event that's essentially triggered every time a transfer has happened. So by saying index events, our CLI is actually going to go directly into the contract, and it's going to find the ABIs that define all of the different events that are available, and it's going to kind of like save that information locally. And if that is confusing, in just a second, I'll show you what that looks like. So anyway, I'll go ahead and just hit enter. This will walk us through a few things. So we're going to choose the Ethereum as a protocol, and that should be like EVM because we have Ethereum in Near, but Ethereum protocol actually also is for Avalanche and all the other Polygon and EVM like Arbitrum. For the product, we wanted to choose hosted service, like I mentioned earlier. For the name, I want to enter in the actual name here. So this would be like Dabit3/CTP API. And then Ethereum mainnet, contract address, we pass it in. And then it's fetching the ABI, which is great. And then the contract name is already done as well. So with that being said, I should be able to go ahead and open this in my text editor. And what we have here is a base code base for us to get started with. And there are 3 main things that you'll end up doing with a subgraph to configure everything. You're going to need to configure your data model, which is your schema. And I'm just going to delete the schema that's there now. You're going to need to define your subgraph configuration, which is subgraph.yml, subgraph.yaml. And then we have to define our actual business logic, which is in this src/mappings folder. I'm going to delete like all of that. We're going to start from scratch. So for our data model, we might think of this as like a good start, this object, because we might want to say we want to have a token, and the token wants to have a description and an external URL and an image and a name and all this other stuff. So we could essentially say that's a good place to start. So to do that, we're going to go ahead and define a token type. And here we have all the different fields that we need. So we have an ID, we have a token ID, we have all these other fields that we're kind of just like setting up. Without going into every single one of them, you'll notice that like description, name, image, and some of these other properties are things that are just off of that JSON IPFS information. And then we also have external URL. We looked at that. And then we have the IPFS URI itself, which is what is like this is right here. So we just want to save all the information on this object and make it available for us to query. In addition to that, we have this like user object, which is it's going to be its own separate type. So I can go ahead and create a separate type here for user. And what this does is it automatically creates a one-to-one relationship between the token and the owner. And it also creates a one-to-many relationship between the user and the tokens that that user holds. And the way that that relationship is done is using this @derived_from directive, which is a directive that we enable directly in the graph node. So when we use that, that's kind of like not a GraphQL specific thing. That's more of a graph tooling specific thing. But by just saying @derived_from and defining the field, we can look here and find the field that we want to derive this from. So this user will essentially just be an address. And then using that address, we can kind of create the one-to-one relationship and the one-to-many relationship back. So this is a good way for us to say, okay, I want to get all the tokens, and then I want to get all the users of that token, or I want to say I want to get this user and I want to get all the tokens that that user owns, and you have that relationship going there. And then the last thing we'll add, and this is kind of optional, is like if you wanted to add full text search, you can add this additional different definition, where we give the search query a name. We tell it which fields to include and which entity to include. So we're just saying we want to use the token entity, which is, right up here. And the fields that we want to be searchable are the name, the description, the type, and then the sun, moon, and rising, which are kind of like their, I forgot what you call them, but like Capricorn, stuff. So, all right. So with that, we have our GraphQL schema, and we're now ready to go to our configuration. So the subgraph.yaml is where you have all of the main configuration. So here we have our address, we have our ABI, we have our entities, which we'll go ahead and delete for now. And then we have our event handlers. So the event handlers are what I talked about earlier. And by passing in index events, it went ahead and pulled down this ABI's, JSON information. And for every event that's in our smart contract, it automatically just saves all that here. So we don't have to go find it. So if I look for event, then you'll see, okay, I have 4 events that are available. So if I go to my subgraph.yaml, you'll see that we have 4 events that were, defined for us. But the only event that we're interested in indexing for this demo is going to be the transfer event, because the transfer event in an ERC 721 contract, an NFT contract, is fired when a token is minted, but also when a token is sold or transferred to someone else. So just by tracking the single event, we can actually keep up with the state of all of the NFTs in the entire, on the entire contract. So therefore, I just want to delete all this other stuff. I can say, I don't want any of these other event handlers. The only event handler that I want to keep up with is this transfer event. And it just makes it, a little bit simpler to look at. So the only handler that we want to deal with is that. And then we want to fire a function called handle transfer, which we're going to handle in our own code in just a second. And then the 2 entities that we want to map are going to be the ones that we defined earlier in our GraphQL schema. We have the type user and the type token. So I can just type token and user, and that maps directly there. And then the last thing we want to do is to update the start block. So I'll say start block is going to be this number. And this is basically going to be the block at which the smart contract was deployed. And this is optional. If you don't add this, it's just going to start indexing from the Genesis block of Ethereum. And it just takes a lot longer to kind of get to where they find a transaction for this address. But if you just define the start block, it just ignores everything prior to that. So it just saves a lot of time. So our configuration is done. Our mapping is done as well. I'm sorry, our schema is done. The only thing we have left is our mapping. And before we do that, we're going to need to have a couple of things available for this mapping. So in the mapping, we're doing a couple of things. We are, the main thing that happens here is when an event is fired from our contract. So the transfer event, for example, it's going to call a function called handle transfer in this code that we're about to write here. And within that function, we need to save information to our database. So we're going to have access to this graph node, which is essentially a Postgres database. and we need to save information there. So we need to have APIs to talk to the graph node. We also might want to talk to a couple of other HTTP resources. One might be something like IPFS. So using that IPFS address, we might want to call and get that metadata. And we also might want to talk to the smart contract itself. So using the token ID, we might want to get information about that token as well. So to get the APIs to do that, you can use the graph TypeScript library, which is actually already included here. So if you go to the dependencies, we have graph TS and graph CLI. So we have access to this graph TypeScript library. And instead of writing all that code from scratch, we can actually generate some code using the graph CLI. So I can say graph code gen. And this is going to give us APIs to talk to the graph node as well as the smart contract that we're going to be interacting with. So once that stuff is generated, we can go ahead and import these types and these APIs that are going to be available for every single contract that you create a subgraph for, as long as you've defined your schema properly. So you'll see that we have a very close mapping between the GraphQL schema that we created with token and user, and we have that available in our schema here. So token and user. And then the only contract that we're really talking to is that token contract. So we have a way to do that. So this is like us being able to talk to the actual NFT smart contract itself. And then the token and the user, these allow us to talk to the graph node. And the main thing that we're going to be doing there is just saving information. We also want to define the base IPFS hash because we need to talk to IPFS. And this is the IPFS hash that I mentioned earlier, where if you go to the smart contract and you go to get base URI, then you have this here. So this should match. Yeah. So that's kind of where that IPFS URI comes from. And then we have this handle transfer function. And this function is going to fire every time an event is triggered from that smart contract. And this is a lot of code. I'm just going to copy and paste this. And I'll walk through a little bit of it, but I probably won't walk through all of it. Let me make this a little bit better. Okay, there we go. Okay, so we have this handle transfer function. The main thing that is actually happening here is every time a token is minted from the contract, this function is fired. Every time someone transfers that token to someone else, either from selling it or just sending it, this function is fired. So every time anything happens around changing the owner of a token, this function is fired. We just want to be able to, handle that transfer event and update our database with that information. So the first thing that you might come to mind is like, okay, if this is being fired both when the token is created as well as when it's transferred, then we might need to first check and see if the token has even been created the very first transfer or not, because the first time this thing is minted, we haven't actually saved that yet to our database. But if someone then transfers it to someone else at a later date, it's already there, so we don't have to create it again. So the first thing you might do is, okay, let me check and see if this token is there. If it's not there already, we're going to go ahead and create it. So that's what these first two lines of code are kind of doing. We first try to load the token using the token ID from our database. If that token exists, we will just essentially like continue on and keep going. And there's not a lot of code after that, right? Because like all we're changing at that point is the owner. But if the token does not exist, we literally have to go ahead and create that token with all of the metadata. Metadata isn't changing, so we just need to create it this first time. So this is a lot of code that's kind of doing that, where we're going to go ahead and create a new token. We're going to add all the different properties like name, description, token ID, all of the stuff. And the way that we're going to get that is we're going to be calling IPFS. So this is kind of a lot of cool code that I'm not going to really like walk through because I think it's not necessary to kind of understand each line of code. But the general idea is the token doesn't exist yet. So we need to go ahead and talk to the smart contract to get some information. We also need to talk to IPFS to get the rest of the information. And then we're going to just like create this token and we're going to add these different properties. So you can think of this as like an object or a map where we're going to add, we have a token object where we're going to add in the name, the image, all these other properties. And then once we've built up this object, we can just call token.save. And this is just going to save that token. And then now when someone wants to query it from our API, it's there. And we do the same thing with the user. The user exists, we do nothing. If it does not exist, we go ahead and create the user. And that's about it. So using this combination of our schema, our mapping, and our configuration, we should be able to go ahead and deploy this. So the next thing that we're going to do is we want to go to our CLI and we want to go ahead and authenticate. So to do that, I can say graph auth and I can pass in the deploy endpoint. And this is all available. Like if we go here to deploy commands, so you have graph auth. Well, actually, we can just do this -- product hosted service. This makes a lot more sense. Okay, cool. And then we can just pass in our access token. And then we can say graph deploy. And then I'm going to say,
Do you need to redeploy it every single time you make changes to mapping
Yes.
TypeScript file?
Yes. Because like, you know, that's going to essentially change the functionality or change the data that's being. So like if we deploy correctly, you should see that this build completed, deployed, and then we should refresh. And then we should see that the syncing has started. In this case, it's synced, but there wasn't a ton of like, this isn't like a DeFi, you know, project where there's probably like tens or hundreds of thousands or even millions of entities. Like this is just an NFT. So like it went ahead and indexed all of these entities. So, and it synced all the blocks. So we should be able to go ahead and test this out. So yeah, I can go ahead and run a query. And here we have our external URL. And I might try, let me go ahead and copy this query over here where we kind of get all the different fields. Here we're getting like the ID, the image, all this other stuff. And we can do full text search. So let's see here, what might we search for? Like a type maybe? Is a type something we indexed? Let me try that. So I might say took, or was it Coven search or something like that? Text would be something like Witch of Woe. And I think we need to add quotes around that. It's going to be more than one word. There we go. The full text search is working. You might want to change the order direction. Let's say we want to order by the last one that's been transferred. So there we're kind of like saying order direction is descending and then the order by is the updated at timestamp. And then we can do filtering. I have this query set up where we can say we want to query where their zodiac sign is for the sun as a Capricorn. And then we have that. And then the cool thing about GraphQL is like you can just add, you can just return the information that you want. So you don't have to return all of this information. You can just return whatever you like. So yeah, so we have this pretty rich API, and I know that was a lot of code and probably fairly quickly, but this is an entire blockchain indexer that's been set up for you. And like people used to spend like weeks or months on doing this. So the fact that we can do it in like 30 minutes is pretty cool for most people that have like faced these challenges in the past. And we use this NFT smart contract, but you know, you can use this for literally any smart contract at all, like anything at all. It could be DeFi, it could be, you know, gaming, it could be anything. So I think NFTs make a lot of sense for a demo like this because it's visual and it's nice to be able to just like look at the tokens. But the people that are like leveraging subgraphs for the most part, I would say for the more highly used projects like Uniswap are typically like financial applications.
That was awesome.
Yeah.
Yeah, thank you.
So I actually have a code base that if anyone wants to follow through, this was a workshop that I did in ETH Denver. And literally the code that I just wrote was just a copy of that workshop. So it kind of worked out great today. But if anyone wants to follow along that exact code base and everything I walked through, I just linked to it there. And you could have a link to this final code base as well as each and every step that I walked through. So if you wanted to try to build one of these yourself, then this is like probably a really good place to start.
I like it. So one question that I have is when you want to write these queries outside of like the subgraph studio or the hosted service studio or the playground, like how do you write these queries like in a React app, for example?
Oh yeah, good question. So if you've ever looked at like the GraphQL ecosystem in general, there's a couple of different client libraries that are mostly used out there. The two main ones that I would probably recommend are Apollo and Urkel, URQL. Both of those are great. And let me actually share my screen. Oops, again. So if you have deployed an API, like you have this dashboard, you have this API endpoint right here. And using this endpoint, which is like HTTPS, API, the graph.com, whatever, like you can actually just drop this into your app and start using it. And then you are going to use the GraphQL client library of choice between, Apollo or Urkel to then send these types of queries. And these are just going to be like, just like we're writing them here, like the way that we wrote like a text like this, you essentially are passing these queries in as a string to the GraphQL client, just like you would any other GraphQL API. So we give you the endpoint. You then just go grab any off-the-shelf client like Apollo or Urkel, and all the documentation should be there for those. And it literally just works the way you would expect. We also have a couple of videos just showing how to do this. So if you go to the Graph Protocol YouTube, I have a video about how to query a subgraph from your front-end application. And it literally probably takes about 2 or 3 minutes to walk through that video. It's very simple.
Yeah, that was fantastic. I really appreciate you taking the time to come and chat with us today. It's really inspiring, and it's also awesome to see all these things coming together and see how we can get involved.
For sure. No, I'm happy to join. Anytime I can have the bandwidth to do stuff like this, I would love to. And it's actually pretty much an honor to be invited to like a blockchain group within the college like this to talk, because I did not actually go to college. And, it's one of the things that I wish I had done, gone to and taken computer science. So it's really cool to actually be participating, since I wasn't able to when I was younger.
And then another thing too, is like something so I'm learning all this at the same time. As Max said before, Cal Poly is a fantastic computer science school, but they don't really have that much news or information on blockchain. Mm-hmm. So we're just like diving in and figuring these things out on our own. I see how much utility can come from something like the graph, but do you think it's a better idea to just dive in? Or would it be better to like really understand GraphQL first and then get into it? You know what I mean?
Yeah, I think the good thing about the graph versus, so I've been working in GraphQL for like 4 years, by the way. I was working a little over 4 years at AWS. We had launched the first GraphQL, I would say we launched the second most highest used API gateway at AWS called AppSync, and it used GraphQL. So it was kind of like the most used GraphQL service in the whole like AWS. And we iterated on it and did a lot of interesting stuff around scalability. Like we had Ticketmaster hitting it with 1 million requests in less than a second, all real time with subscriptions, and it was really crazy. And there was so much complexity when you start trying to scale out these real-time GraphQL endpoints. And the thing that I thought was interesting about the graph is that you don't actually have to understand all of the backend stuff about GraphQL. The only thing you really need to understand is consuming it from the client and just understanding data modeling in general. And it's not really GraphQL specific. So I think I wouldn't worry about GraphQL. Instead, I would just focus on understanding just how the GraphQL schema works. But that's really basic stuff. It's almost like learning a typed language like TypeScript or whatever other type languages that you might be using yourself. And you have like how we might have a class with like a property, it's kind of just like that. And once you understand just data modeling, then everything else is pretty straightforward. The only time you'll end up using GraphQL is just in the querying part, and that's fairly straightforward.
Awesome. Thank you.
Yeah, thank you. Really appreciate it, Nader.
For sure.
Is there any way we could like stay in touch with you?
Yeah, I mean, you can connect with me on Twitter. I mean, we have a DAO called Developer DAO. I don't know if anyone's interested in DAOs. Do you all know anything about those? Decentralized autonomous organizations. Yeah, some people are, some people, yeah. So like there's a DAO called Developer DAO. We're about to be opening up sponsorships for joining the DAO, and we have a lot of students that are in there already from around the world. If you're already into Ethereum and like blockchain tokens and stuff, you might have a little ETH, you can actually pick up a token off the secondary market, because we had a completely free like mint. Everyone was yeah, thanks. And then the website is a little outdated because we just opened memberships back up last week. So let me give a link to our Twitter. So within the DAO, I'm sorry, go ahead.
I was just gonna say, like, in order to get the membership, you had to mint one of the Developer DAO NFTs. You don't have to do that anymore.
We had like a free contract where it was free to mint for like a few months, and then we sold out, or not sold out, but minted out. And now the only ones that are available are like the ones that are on OpenSea, but we actually have about 200 that are set aside for scholarships, and that we're going to be doing a giveaway hopefully soon. So you can pick one up of OpenSea. You can wait till we do our scholarship program, and you can get one for free at that point, but it might be a couple of weeks. But the Developer DAO is cool because we have a lot of really great conversations there. So many people have actually picked up jobs and worked there. We have protocols, like every single protocol is in there, like Polygon, Optimism, like Solana. All the people are in there that work at those protocols, and you can actually get to know them and stuff. It's pretty cool.
Yeah, I learned a ton from this. Thank you. Excited to kind of look into it more. I studied information systems, so a lot of like the database management, stuff like that. You can see the parallels, and it's exciting. Oh, sorry, you're on mute.
Oh yeah, sorry about that. No, I just now also, by the way, linked to that defining the Web3 stack blog post that I was mentioning earlier. So yeah, a lot to dig into there as well.
This stuff is honestly like a lot more interesting than like a lot of the popular DeFi stuff. That's what I like about it. It's like Web3 specific, but it's not like cryptocurrency specific.
Yeah, I think diving into or looking at blockchain from the perspective of understanding all the ecosystem makes it even more compelling, because like, yes, you have DeFi, but you also have all this other stuff, and often they overlap. So you have artists and you have developers, and you often have DeFi stuff all kind of like overlapping sometimes in the same project. And it's a lot more exciting than the traditional world where I was just building out stuff for just, I don't know, like businesses that were doing really boring stuff. And now we're like at ETH Denver, and there's like actors and actresses, and there's artists, and there's musicians, and people putting together parties, and you're working together, and it's just so much more fun. So it's definitely not boring. Blockchain is probably the most fun space I've ever been in, for sure.
Well, thank you again for your time. I got to take off here, but really appreciate it, and looking forward to digesting all the information you gave to us.
Cool. I'm going to run as well. So thanks everyone for having me, and it was nice to meet you all, and good luck, and keep going.
We'll be in touch.
All right. See y'all later.
Thank you.
Thank you.
Take care, you guys. Have a good
Thanks,
one.
everybody. Thanks, Max. Thanks for seeing you.
Peace.